A very good morning, students. Welcome in another lecture of chapter 2, Is Matter Around Us Pure? So till now what we have discussed? We discussed about the matter, what do you mean by the term pure, and about the mixtures and little bit information about the solution. Okay. So again here I will explain you once more that what do you mean by the term solution. So what do you mean by the term solution? As we know that the solution is a homogeneous mixture, right? That means property of the solution will be same throughout. Okay? And in case of solution, as we have seen that two or more substances, they will lose their identity and they cannot be separated by the simple method. Right? Till now it is clear to everyone. Okay, now see the second version, that what is solution? Solution is nothing but a combination of your solute and solvent. Right? If we are having the one solute and the one solvent, we call it as binary. We will use a term binary. Binary means two things. That means we are having the one solute and one solvent. Sometimes we may also have two solutes and one solvent too, right? But here we will take only binary solution. We will discuss about the binary solutions only, okay? So here, how you will identify in a solution which component is your solute and which component is your solvent? Have you like this type of question comes in your mind? Yes. So here I am going to tell you the two methods by which you can decide that which component will act as a solute and which component will behave as a solvent. Okay. So the first method is the component which is present in more amount, we call it as solvent. This is a general view, right? The second method is the physical state of the solution will decide that which component will act as that solute and solvent. Suppose you are having a sugar and you are having water. What you are going to do? You are going to prepare a solution of both of them, right? You dissolve this sugar into the water and now you are having a sugar solution. So tell me the physical state of that solution. It is liquid or solid? Yes, it is liquid. So now check from your constituent part, that means from your component side, that which one was present as liquid. Obviously water, right? So here the water will act as a solvent. So the physical state of the solution will decide that which one will act as a solvent. If the physical state of the solution is liquid, then the liquid part will act as a solvent and the another one will obviously your solute. So here I have written one example as 20% of ethanol solution. Imagine you are having a 20% of ethanol solution. So that see, ethanol solution, that means ethanol is dissolved in water. As they have written that 20% ethanol, 20% means 20% ethanol is present in 80% of water. Okay. So here you can say that ethanol is acting as solute and water will behave as a solvent, right? Because of the more amount of water, right? Now the one question will be coming in your mind. If it is 50%, right? Maybe 50%. So in that case, you can select either of them as the solute and solvent. Now see some more examples of your solution, right? See, the first one I have written solid and liquid. Now you can tell me a number of examples I know. I have written the one iodine in alcohol. Suppose you are having the iodine which is solid and alcohol is liquid. And what you are going to prepare a solution of from both of them. So this is a combination of solid and liquid type of the solution. And here this combination iodine in alcohol is called as tincture of iodine. Okay. Sometimes they will ask you what do you mean by the tincture of iodine. Second case, gas in liquid. So gas in liquid, have you seen some this aerated drinks, that means cold drinks and all, soda water? Yes, their carbon dioxide is present as a solute and water as solvent. So gas and liquid, you can write examples of your soda water where CO2 will act as a solute and water will behave as a solvent. Okay. One more example I have written, gas in gas. So here A very common example you can take as air, and air is a combination of number of gases. Okay, I cannot write the name of each and every gases here, so I have just mentioned oxygen, nitrogen, as oxygen is present as 21% and nitrogen as 78%, and the rest are your other gases. So here all these are the example of your solution. Now see the properties of solutions. Okay, so solution is a homogeneous mixture, that is very much clear to everyone now. So particles of solutions are very small. The particle size is smaller than the 1 nanometer. So what is 1 nanometer? 1 nanometer means 10 to the power minus 9 meter. That is why we cannot see them by our naked eyes. Okay. The second is what? The solution, it will not scatter a beam of light. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. Okay. So that is why they do not allow to scatter a beam of light passing through a solution. Okay. The third point is they cannot be separated by the filtration. Filtration means what? The solute particles cannot be separated from the mixture by the process of filtration. Once you will get the solution, you cannot separate it by the filtration. Okay. And the fourth point I have written as stable. Stable means what? When they are left untouched. That means once we form a solution and we kept it somewhere and we will not touch it for some time, the solute particles will not settle down at the bottom of this beaker. So what we will say that these are stable. Stable means what? When left untouched, the particles will not settle down. Okay. The solute particles cannot be separated from the mixtures by the process of filtration, and the solute particles do not settle down when left undisturbed. That is why we call it as stable too. Okay. Concentration of solution. So the concentration of a solution depends upon the amount of solute. So if the amount of solute is very less, we call it as dilute solution. Okay. If the amount of solute is more in the solvent, we call it as concentrated. And sometimes we call it as saturated solution. So what do you mean by the saturated solution? As we know that at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving, we call it as saturated solution. Or we can say when no more solute can be dissolved in a solution at a given temperature. It is called as saturated solution, right? So amount of solute present in the saturated solution at this temperature is called the solubility. So one more term, solubility. Okay. What is solubility? The amount of the solute present in the saturated solution at this temperature is called the solubility. If the amount of solute contained in a solution is less than the saturated level, we call it as unsaturated solution. So here two more new terms you learn: saturated, unsaturated, and one more term related to it. It was solubility. Okay. Now see the some concentration terms, and we will discuss these terms in detail in our next lecture. So here I am going to give you the brief description of the concentration terms. The first one is your mass by mass percentage. In short, we will write it as weight by weight percentage. Okay. So what is weight by weight percentage? It is equal to the mass of solute upon mass of solution multiplied by 100. Because I have written weight by weight, that means we need to take mass of solute and mass of solution. Right? The second number is mass by volume percentage. In short, we will write it as weight by volume percent. Okay? So here weight by volume percentage is equal to the, because weight, mass of solute, and here the volume, that means volume of solution multiplied by 100. Okay? The last one is your volume by volume percentage. That means V by V percentage, and here how we will define it as V by V percentage is equal to the volume of solute upon volume of solution multiplied by 100. So all these concentration terms we will use in this chapter, and I will give you the some numericals which will be based on these concentration terms, right? So in our next lecture I am going to give you the detailed description of all these concentration terms, and this is all about this lecture. Thank you.